Hi everybody and welcome. Today we're going to be working on compound inequalities. So your goal after watching this video will be able to solve inequalities that are compound, or a really fancy way of saying solve two inequalities at the same time. So nothing new in terms of actual skills that we're going to be using on this. The only difference is we're going to be doing two of the same thing on the exact same number line. So one more step in terms of getting a little bit more advanced, but like I said before, the actual mechanics, the actual step-by-step of solving is the same. We just add one step by putting two together on the same number line at the end. So our word for today is compound inequality. And our definition is two inequalities joined by the word and or the word or on the same number line. So we'll go over two different types of examples, and examples and or examples, and typically, not all the time, but typically what they look like. So an and example would be something like x is greater than 4 and x is less than 9. So what we do on a number line, start off with the number 4 and the number 9. Greater than 4, so we're going to go to the right. Less than 9, so we're going to go to the left. And the and inequality, what this really does is we see those two arrows go towards each other. It just changes this from being two separate inequalities to one inequality with a start point at 4 and an end point at 9. So that's the idea of looking at what an and compound inequality looks like. Now an or compound inequality is going to look a little bit different. So you can do x is less than 4 or x is greater than 9. If we put this on a number line, the difference with the same numbers is we're going to see we're going to be less than 4, so we're going to go to the left, greater than 9, so we're going to go to the right. Typically, or is going to go away. So what that means is there's some kind of gap in the middle, so we're going to have like one set of answers that could be less than 4, and then a separate set of answers that could be greater than 9. So typically when you see an and, it's going to look like the first picture. Typically when you see an or, it's going to look like the second picture. Steps for solving these, though, when there's multiple steps in the equations. First, we're going to want to isolate the variable. Again, a fancy word for saying just get the variable alone. Next step, we're going to want to graph that solution on a number line specifically. So we're going to be graphing on a number line. And then finally, we're going to combine the graphs. So we're going to have one graph for each one to combine to 2 total. And we're going to put those on the same number line. So combine the graphs, and this will represent your compound inequality. So we're going to go through a couple of examples here. Just like the other video the other day, I'll do one, then I'll ask you to do a very similar one, and we'll do that a couple of times, and that'll take us to the end of the video. So for our first one, we're going to see two different, and I'll put them in two different colors. So we'll see the blue inequality here, x minus 7 is less than 2, and we'll do a red inequality, 2x plus 1 is greater than 9. So those are the two inequalities to solve. So our first step is just isolate the variable or get, x by itself. So for the first one, in blue, we'll just add 7 to both sides. We'll end up with x and a 9. And that inequality sign, we didn't multiply by any negatives, so stays the same. So x is less than 9. So let's jump right down to a number line. Let's throw 9 on the number line, and let's in blue graph it. So starting at 9, nice open circle because there's no equal to. X is less than 9, so we're going to go to the left. And there we go. There's our blue answer. Let's find our red answer now. So same deal. We want to get the variable alone, so we'll subtract 1 from both sides. Let's get 2x equals 8. Divide both sides by 2, and we'll get x and 4. No multiplying or dividing by negatives here, so the sign stays the same, so we'll get x is greater than 4. Okay, back down to the number line over to 4. Starting off with an open circle again, and we're going to the right because it's greater this time. So what we can see is these go together, it's an and, they converge. So like we mentioned the example above, we can just simply extend this line, and this is our interval. Interval notation, open circles mean we're going to be using parentheses. The number is 4 to start, and the number is 9 to end. So that's going to be our answer. X is on the interval from 4 to 9. So now what I'm going to ask you to do is the same idea. Work through our second example here, question number 2, and I'm going to put the question embedded in the video here. We'll hit the pause button, I'll have you submit that answer, and then we can move on to our next one. One thing I do want to note about this question, please make sure with this negative sign here, that is going to mean that we're going to be flipping our sign. So be careful with that negative sign because that will end up with a flipped sign. All right, the second set of questions, the second types that you might see here, taking a look at these, are when there is no words present, they just give you 2 inequality signs. So that's just a really fancy way of saying you just got to break them down. So just like above how we had one in red and one in blue, we're going to do the same thing. So again, above we solved one in blue, we solved one in red. So let's do the same thing. So our blue one is this inequality right here. So I'm just going to write that right below. 5 is less than 1 minus x. And then we'll also have a red inequality. We always use the middle twice, so we're going to have this 1 minus x again. And then we'll also have our less than 9. So we'll have second one, 1 minus x, less than 9. So it's going to be a good example, or a few things that we'll be able to go over on this one that are honestly pretty commonly tricky things. So get the variable alone, we can subtract 1 from both sides. So we'll have 4 and minus x. We need to get x alone though, so we need to get rid of that negative. So divide both sides by -1. Because we are dividing by a negative here, that does mean that we are going to need to flip our sign. So we'll end up with -4 on the left, flip our sign the other way around, and keep the x. So that's our first one, x is less than -4. Jump over to a number line. -4, graph it in blue, open circle because it's just less than, and x is not being eaten, so it does go to the left. So we're going this way. All right, let's solve in red now. Same deal, subtract 1 from both sides, so we'll have minus x and 8. Divide both by -1. Again, dividing both sides by a negative means we are going to flip that sign. And x is greater than -8. So we start off at -8, which is right here. Open circle, going to the right because it is greater than, is eating the x. So we're going to have our interval here. So interval where these things come together, they're pointing at each other, so it tells us this. So just like before, both open circles, so both parentheses, start on the left with -8 and on the right with -4. And that's actually going to be the full answer. X is anywhere on that interval for that inequality. So same thing as before, going to take a look at our second question here. And hit pause on the video. I'm going to ask that you solve that second question. So again, right where the star is, if you can solve that one right on the right, put your answer in, and then that'll take us to the end of today's video. Once you're done with that, you're ready to move forward. If you got questions, obviously let me or anyone else know. Happy to answer. And you're ready to move on to the next assignment. Thanks so much for watching. As always, we're here to help.